We're doing it. So this is question 19, I think from chapter 8. They say consider the network in problem 8, but with the following new time estimates for each activity. So they give us the A, M, and the B for each activity. The A is the optimistic time, M is the most likely time, B is the pessimistic time. So the longer the time is, it's like worst case scenario. That's how long each activity is going to take. Best case scenario, and then more realistic, more likely. That's how long each is going to take. So we're going to talk about each of these things. This is that path they're talking about from number 8. Circled in green, we have the numbers of the activities. So node 1, node 2, node 3, node 4, and so on are the number activity 1, 2, 3, and 4, and so on. I've gotten rid of the numbers that were on the bottom because those were the old activity times, but I've applied the new activity times. Specifically, these are the means. Actually, we'll see the means in the Excel document. So not the most likely time, but the actual means, the correct means for A, M, and B. So just to get a glimpse of the Excel file real quick, that corresponds to this. So they've translated the chart we were just looking at into Excel: optimistic, likely, pessimistic. And you find the mean by doing this weighted average. So you do the first optimistic time plus 4 times the likely time plus 1 of the pessimistic time. So you do 1 times 4, or 1 and then 4 times this and then 1 of those. So you have like a count of 6. So you're counting the first one once, the second one 4 times, the last one once. So you have 6 things, so then you divide it by 6 to find that average, that weighted average. So you're weighting the likely time 4 times as much as the other 2. Could have just said that. They do that for all these values, for all these values. They find the means of every single one. These values, these means, are what is on the bottom of each of these nodes here, okay? So we'll talk about that more in just a minute. Let's talk about how they found standard deviation. We can see it in the calculation. Standard deviation is just pessimistic minus optimistic divided by 6. And then every time, variance is standard deviation squared. So notice they'll just take that value and square it. So knowing how to do these calculations is very important. We'll refer back to this chart once we do a little sketching, do a little by hand work here. Let's see if we can do this. What we're going to do is figure out earliest times, this stuff here. So expected activity times, earliest times, latest times, slack, critical paths, and expected project duration and variance. So starting with earliest and latest, expected activity times. Expected activity times are just going to be the times that I put here. These come from the means that were calculated, right? So now we're going to do that little earliest start and finish time, latest start and finish time for all of them. So typically you'll see it as like a 0 to 2.5, 0 to 2.5. Since we're starting at time 0, and this is going to take roughly 2.5 units. Are we talking days? I don't really. Yeah, days. So days. So first activity is going to take 0 to 2.5 days. Latest and earliest and latest start and finish times. Okay, because it's the only thing we have to do right off the start. So we got to knock it out. It's going to take 2.5 days. Okay. Now, moving on to activity 2. This is going to take 3 days. So the earliest they could be done would be 2.5 to 5.5. So they could be done at the earliest at 5.5 days. We won't be able to tell how early we could finish, like at the latest, until we do some of these other ones. So now let's move on to node 3. We have activity 3, which is going to take 5.5 days. So the earliest we could be finished would be 2.5 plus 5.5. So that would be 8. Yeah. So the earliest we'd be done, the earliest finish, is 8 days for activity 3. Now let's go down to 4. This is going to be where it gets annoying. 2.5 plus 6.83. So that's going to be our earliest finish time. 2.5 plus 6.83.
The answer is 9.33.
All right. So the earliest we'd be done with activity 4 is 9.33. Now, what we have to do, I'll kind of demonstrate it with nodes 2 and 3 as they go to node 5 here, activity 5. They, like, I'm trying not to talk over myself. So 2 and 3 have to get done, and then they go to 5. The big thing is, like, they're going to get to 5 as early as they can, dependent on, like, how long 2 and 3 are going to take. Activity 3 takes 5.5, so it takes much longer than 2, right? So the earliest you could knock out both 2 and 3, then get to 5, the earliest would be 8. So the earliest start time for 5 is 8, because the earliest finish time for that is 5.5, but the earliest finish time for number 3 is 8. So they're like 2 and 3 are not going to be done until day 8. So that's what allows you to then start activity 5, which is going to take 4.5 days, which means earliest finish for 5 is probably 12.5. That's 8 plus 4.5. Now, step back a little bit. Because activity 3 is going to take up until 8 days, but then activity 2 is being done in that same time frame, that means that you have some wiggle room. You have some slack time for activity 2 that you can, you have until day 8 to finish activity 2, because you're kind of relying on, like, activity 3 is going to take at least until day 8, right? So you have until then. So we just have to think about, like, what's 8 minus 3? That's 5. So you could either earliest finish for activity 2 would be 2.5 to 5.5, and then latest start and latest finish would be 5 to 8. And again, that's all because 2 and 3 have to end up at the same spot. That's activity 5. And so it's like all the in-between activities you have to do that end up at the same place kind of determine the slack time for each other. So, like, the activities that take longer, they're going to be what's known as critical. They're going to be the ones that do not have slack time. The activities that take the longest are not going to have slack time, because they're going to take the longest, and the other activities that take less time have they have more wiggle room, because the other activities are going on at the same time, roughly. And yeah, I don't know. That's the best I can explain. So that's the best I got there. Let's see if I can do, like, a couple more. I'm not going to do this whole thing just on account of how time consuming this already is. Let's see. So biggest thing, so far we know activity 1 is critical. Activity 3 is critical. Activity 2 is not critical, and it is not critical because it has slack time, because the earliest start and finish is not the same as the late start and late finish. But for activities 1 and 3, the early start, early finish, late start, late finish are identical. So that's what tells us whether something is critical or not. If they have the same times, critical. If they do not have the same times, not critical, therefore they have slack time. Slack time means not critical. Okay, so then you go through this whole thing, kind of doing the same approach here. I'm assuming for activity 5 here, there might be some slack time. It would be all dependent on, like, the endpoints of all the others. Yeah, so basically this is just like a rough start, and then I'm going to use I'm not going to go any further with that, but we're going to look at the Excel file and kind of compare some of the answers we just got there, right? So we can see activity 1, early start, early finish, late start, late finish. That's the 0, 2.5, 0, 2.5, right? Make this a little bit bigger. All right, and then activity 2, oh, look at that. I even had that wrong, I think. So 2.5 to 5.5. And then they had 7.5 to 10.5. So maybe there was an even... Now, how does that make sense? Activity... Oh, wait, no, that's activity 2. Yeah, activity 2. So that's pretty interesting. So what did they say for 3? They said 2.58, 2.58. So we had that right. That's kind of interesting. Now, why would we have that much time for... Hold on. because 2 goes to 5. Slack time. Okay. We had the early start, early finish right for 4. We can see that down here. But now, what would have allowed that to be so loose for number 2? I don't really agree with that. I don't understand why it would be. I don't know. I thought I was crushing, I'll be honest. But hopefully you're still getting something from this video. I'm doing my best here. So number 3 was critical. We had that. Now why is that 7.5? Because this has got to be done at 8. So what allows the extra slack time all the way to 10.5? That doesn't make any sense. I don't know. Either something was calculated wrong or I'm just not fully understanding this here. But moral of the story is 1 and 3 were still critical. Okay? And that meant 2 still had some slack time, which meant that 2 was not critical. And I don't know, it's like the best I got there. I think maybe it's just a matter of like eventually, and I don't know. I don't want to try to put reason to it. So let's see if we can talk about some of the other things. Expected activity times, covered those. We covered some of the the earliest activity times, latest activity times. Obviously, all the activity times, earliest, latest, expected, all those are right here. And then activity slacks are right here. As a reminder, the slack time is like how much wiggle room they have. So like, I guess for this one, the slack time is like the difference of the late start and the early start, or even the late finish and the early finish. You find the difference between those two. So I would have thought the slack time for number 2 was 5 minus 2.5. So I would have said it was 2.5, but they said it was 5. So slack time, you do late start minus early start, or late finish minus early finish. Critical paths. Again, critical paths are the paths you would take along the critical activities. The critical activities are the ones where there's no slack time. No slack time visually are like these, the 0 to 2.5, 0 to 2.5. The earliest match the latest. Earliest match the latest. So like activities 1 and 3, critical. I'm assuming 5 is critical. I'm assuming, actually, no, they might not be because the other ones might take longer. So, you'd have to do the whole, chart for this. I guess that's why they obviously did it in Excel. So notice here, whichever ones have a slack time of 0 are your critical activities. So let's see if we can highlight these. 1, 3, 7, 8, 10, 12. Those are your critical activities, which means 1, 3, 7, 8. So 1, 3, let me see if I can highlight them on here too. 1, 3, 7, 8, 10, 12, 10, 12. So the path I've highlighted here, 1, 3, 7, 8, 10, 12. That's the critical path. So then from there, so that's our critical path. Now expected project duration and variance. I mean, I think that's just going to come from the expected value of the critical path, if I'm not mistaken. So it's going to be like 2.5 plus 5.5 plus 1.5 plus 3 plus 4.5 plus 1, maybe 1. Let's see what they did. Do they have that somewhere? They have project, they have 18. Is that the result of that? Let's see. 2.5 plus 5.5 plus 1.5 plus 3 plus 4.5 plus 1.
The answer is 18.
Beautiful. So that worked out. That's nice. So again, the project time comes from the time it takes to complete the critical path, the expected project time for the critical path. And then variance, I believe, is just going to be a sum of the variances of the critical path activities. Got that? Sum of the variances of the critical path activities. And they actually did that right here. Look at that. So they did the sum of the variances of the critical path activities. Notice how 1 is highlighted, 3 is highlighted, 7, 8 highlighted, bam, bam, 10 and 12 highlighted. They added up the variances. So the project variance is just the sum of these variances, and then you take the square root of that project variance to get the standard deviation of the project time. Okay? that's about all I can do on this one. Actually, you know what? Let's go back to, let's move this over. Let's just look at this thing now. So again, we said that activities 1, 3, 7, 8, 10, and 12 were critical, which is shown in the red critical activity situation here, the red color. Now, the other activities obviously were non-critical, which meant they had slack time. So what it shows, I guess, is like the difference. Let's see if we can. So like 2 was 2.5 to 5.5, and then 7.5 to 10. Yeah, so how they do that? 5.5. So I think it's like 2.5 to 5.5, and then this was just the rest of their slack time. They could have started earliest here, finished here, but they also had this wiggle room all the way up until about 10.5, I'm assuming. Yeah, 10.5 was their latest finish for number 2. So then, again, it's just the same thing all the way through. Like the start of this yellow bar, or like whatever this is, off-white, is earliest start, and then back here is the late finish. Okay, so that plays into the slack time. So that's kind of where this chart's coming from. And then all these computations, I don't know if they ever taught you how to do this because I have no idea where they're getting it. I know where they're getting these, but then like running this whole Gantt chart test thing, I'm not sure. But anyway, I hope you found this useful. Hope there's something good in here. That's about all I got. All right, bye bye.